Hey everybody, welcome to Houdini Hangout. It's the 19th of April. Welcome to the stream. It's been a little bit. Things have been a little crazy for me recently. I've had some internet issues and all sorts of other things going on. So I'm glad to be back with you guys. Hey Zach, how's it going, man? Good to have you with us tonight. Yeah, so a little bit busy recently. You know, I had GDC in the end of March, and then I had to have Spectrum come out to check my internet because it just kept not working pretty frequently. So fingers crossed we're going to have some good internet for me coming up here for the foreseeable future. So so that should be pretty good. Hopefully we'll be a little more steady and not running into any technical issues. Hey KG, how's it going, man? Yeah, back in action. So one thing to note, next week I'm going to be at FMX in Germany, so I won't be here again. But I do have a really cool announcement to make kind of at the top of the stream. I'll mention it before we're done at the end, just in case anybody catches late. But on the 2nd of May, which is actually a Tuesday, I had to reschedule it because a guest that I was going to have on just needed to kind of shuffle around a little bit for the week. And was kind of the right timing for him and for me coming back from overseas and things like that. So on the 2nd of May, we're going to have Mark Fancher from Already Been Chewed on the stream to walk through some of the stuff that he's been doing and talk a little bit about, just some different techniques and things that he's worked on, kind of break down some stuff. It'll be sort of similar if you saw like what we did with Chris Rutledge or with Michael Goldfarb in the past. We're gonna have Mark kind of go through everything that I think he's probably going to break down some of the more recent stuff that they've done and talk a little bit about that. So he was hoping that it would all be live by the time he had the project he was hoping he would have ready to go. So I think he might have it ready to go, but we'll see what exactly he's going to be talking about. He's still got a couple weeks before that'll be happening. But Mark and I met up. Hey, how's it going, man? Welcome to the stream. Yeah, Mark's awesome. He's a really good guy. I agree. KG, yeah, he's awesome. And we met up at a education event in Texas and just chatted for a while, and it was really good. And so we just, I reached out to him recently. I was like, hey, we should do this. We should make it happen. So it should be really good. He's a great teacher and really knows his stuff and is just a great evangelist for Houdini in general. So hopefully it'll be a really enjoyable time and you'll get a lot out of it because I know Mark is an awesome dude. So anyways, I'll mention that again at the end just in case anybody misses it. But that is the plan coming up. So that is kind of all the housekeeping stuff as far as apologies for not being on as much as I would like to, and kind of some of the things that are happening in the future. But for tonight, what I'm going to do is we're going to play around a little bit with some more Vellum stuff. I always like Vellum. It just seems like a really good teaching opportunity. I have some ideas for some courses or for some kind of content to kind of break down Vellum a little bit, because sometimes I think we get hung up on certain things about how Vellum works specifically, but really at the end of the day, I think Vellum is really neat because it's just attributes on points and attributes on lines basically, and just controlling where those are going, and then the solver kind of does the rest, which is, obviously there's a lot going on in there, but I think it's a really cool like teaching and learning opportunity because it's such a Houdini kind of thing. It's very much just the points and lines, attributes, all that kind of stuff, all baked into solving and simulation and stuff. So I really like it from that standpoint. And I think it's cool for a lot of people that are, working as freelancers or, in smaller settings. It's just a really popular thing to use. So I think it'll be helpful. Now, I want to preface what I'm going to show today by saying I would love to know if someone else has a way easier way of doing this, because I thought it was a lot easier than it would be to do this inflation, kind of this random inflation, but it was kind of a pain on some levels. So if anybody's like, hey, dummy, this is a better way to do it, I would love to hear that. So my normal caveat is, if you've got any questions, thoughts, comments, anything like that, drop it in the chat. I'd love to hear, your guys' thoughts. I certainly am not the subject matter expert on all of Houdini, or any of Houdini for that, for that matter. I'll leave that up to the people that actually write the software. But I don't want anyone to ever feel like they can't jump in and be like, hey, that seems like a dumb way of doing that. So if you have an idea, please let me know. You can always drop it in the chat, any thoughts, anything like that. So that's always my little caveat I like to make at the beginning of the stream. But with that said, let's jump over and start to talk a little bit about what we're going to be doing here in Houdini. So I don't remember who I saw doing this, but I think they were playing around with this actually in cinema and made something sort of like this. And I was like, I wonder what I would do in Vellum to make this work. So basically what we're doing here is working with a bunch of boxes, and we're going to randomly inflate them, make them do some cool stuff. So I'll just show you the cache that I have written out here. Oh yeah, cool. Oh, right. I just hadn't moved it. So this is the cache. I'll just play it down real quick so you can see it. So basically we've got some like random balloons blowing up and moving around and, doing their thing. They inflate, they deflate, a bunch of other things, and they just kind of go back. Oh, cool. Hey, yeah, thanks, Waffle. That's really kind. Yeah, the Vex tutorials were super fun to walk through and have. It's cool to have Matt along for the ride for all of that. That was cool. Yeah, super. I'm glad it was helpful to you. It was helpful to me to walk through all that stuff. So yeah, it's there's never even teaching is helpful to learn yourself. So. Anyways, cool. Glad that was a helpful piece of, a series of videos for you. So this is, it's a little different than what the person that I saw online did. This is actually being driven by noise instead of just by an object moving around. Now you could do that just the same as you could with noise. But let's kind of talk a little bit about how I went about building this and doing all of this, and then we can kind of walk through it, see what's going on, try to understand some of the pitfalls that I ran into, and maybe we'll even find a better way of doing this while on the way. So let's talk through it, and we'll kind of go from there. So this is a little different than how I normally do things. A lot of times I've had things where I build them live and just kind of work through them and we chat and whatever, but this was something I was doing on my own, and then I was like, I should really show how I did this, because I think it's interesting and worth the conversation. So what we start off with here is just a straight up grid. Nothing exciting here. But then we're adding in this just a group number attribute here, basically. And what I did here was, the reason I did it this way was because I wanted to start to break this up a little bit based on the different attributes. Basically, I wanted to run a for each loop, do some extrusions and things like that to be able to get the primitives all these individual polygons split up and extruded and turned into boxes and stuff like that. So obviously there's a million ways to do everything in Houdini, but this was just the way that I thought of. So I was like, okay, I'm going to make 7 different group numbers and run them through a for each loop. And when we come down here, maybe we'll just look up here actually. Yep. So this is one of the groups here, right? So this is probably group number 7 in this case. But if I come down here and just do a single pass, we can see how this is being split up. So we're splitting this up into, 7 different pieces here. And because we're using an attribute adjust integer, so we're getting an integer value here. We're having 7 different values of an integer written onto this grid. So it's breaking it up randomly. But what I was then thinking of doing is like, okay, so we can do that first of all, right? So we can get these pieces, but then we can do something like run a connectivity. over them, right? And that will give us a class attribute, right, that we can work with. So now we have, so I'll look at this here. Maybe I'll make this a little bit bigger just so we can see it. So at this point now we have our group number and we have our class. So we're randomly bringing things into this for each loop, and kind of by default, we're getting them split up, right? They're not all like, this is just random polygons, and we have like this chunk here that'll be connected, and this chunk, but like this one by itself isn't going to be connected, and these over here won't be connected, so those will be individual polygons. So it's kind of a way to make different chunks of polygons kind of in a sort of quick way, I guess. So now we know each individual, island of geometry, and we have this class kind of set up. So then what we can do now that we have them all broken out is I just basically inset on the polygon. So I just scaled them in a little bit from their edges, did a blast to remove those outside edges, and then poly extruded them up. So now we have, blocks in this case. And then we do that for all of them. I'll turn off single pass here. And you can see we're starting to already get that that kind of, random shapes. I kind of wanted it to look a little more Tetris-y, but I was having a hard time with it. So I was like, you know what, this is close enough. It does the trick. So, so I started with that. And then here, basically all I'm doing is taking those two attributes and making a name out of it. So this is a really helpful function, sprintf. It's sprintf, but it looks like it says sprint F, so easier way to say it. So what this is doing basically is I'm taking those two attributes that I've created and taking the group number and putting it in here in the first one. And then I've got the chunk, which is going to be the class. So I have my big piece, right? So there's pieces, like this huge piece, and then each of those pieces have chunks in them, right? So you can see down here that this is writing out, piece 7, chunk 2, piece 0, chunk 0. So each piece can have multiple chunks, right? So each of those for loops are going to be one piece, and then within that, anything that's connected together is going to be a chunk. So that's kind of how I'm splitting them up, and it's going to give me some better control over, how each of these are being seen, by Vellum and all that kind of stuff. It's giving me some named attributes, so these are all individually named pieces. So then I'm grouping the edges. I thought maybe I wanted to use the hard edges. I actually think I ended up turning that off. Nope, I did keep that. Sorry. So you could do hard edges here. You could also turn that off, and it's going to soften. It's going to allow those edges to not be as stiff, although in this case it looks like they are staying pretty hard. But, just used an edge angle here. So here I've got it enabled, and I've got the set minimum edge angle, and that's what gives me just the edges here and not anything that's, kind of planar to the adjacent polygons and stuff like that. So just basically is whenever the angle is over 20, that's when it's going to put that edge into the group. And I'm remeshing it because in Vellum, it always is, you want a little bit more density of points, right? You want there to be a little bit. Thanks, man. I appreciate it. Yeah, cool. Yeah, you can always drop some likes. I'm not here for the monetization or anything like that. I'm just here to help. So as long as you guys are feeling helped, that's great. But I do appreciate any, whatever help that does to the algorithms or whatever. But yes, thank you, Jonathan. That's awesome. Okay, so this is, we're remeshing it here. And just something to keep in mind when you're using the remesh, there's a couple different ways you can go about kind of manipulating this, right? You can change your target size here, right? So this is going to change the edge lengths, right? But another thing that you can do to help make this maybe be a little bit of a nicer mesh sometimes is by upping your iterations here. So this is actually going to it's actually going to kind of make these a little bit smoother sometimes. Now, I didn't really feel like it really needed that in this case, but just something to keep in mind when you're working with the remesh node. That is, the more iterations, the more this smoothing is going to be applied. And obviously the more smoothing you apply to it, that also can affect it as well. So there's kind of a couple different ways that you can kind of push those things around and make them work. So those are the things that I'll play with when I'm doing that. But this felt like a pretty good number of points. I didn't really need it to be too dense. because usually the more dense it gets, sometimes the more unruly it can be to kind of work with. And you get a lot of the details anyways with a grid I felt like that was about this dense. So anyways, that's where we're at here. So let me see what I did here. So this is a distance from geometry node. What this is doing is it's actually creating a distance attribute based on its distance to this grid. So what I was doing here, yes. So I could have just set it to be anything that was over a certain height or whatever, but I don't know. I just set it this way with a distance this way. You could do it with the y at p.y and have a threshold there for that. That's a way to do it as well. Sometimes I'm just doing things and, maybe this just shows you something a little different. But so what this distance from geometry is doing basically is looking at this grid here that I have. It's looking at the second input and saying what's the closest, how far are all these things to that grid? And then based on that, gluing them, adding these points, which I'm going to use to glue these boxes to the ground. And I'll show you kind of the difference there in a second, how that looks a little bit different. Because I really wanted these to not just kind of blow around, right? So sometimes you have to think about when you're working with a simulation, like what's your desired look, right? Because if you just let these things kind of inflate and blow up like a balloon, well, they're going to push up from the ground naturally because they're getting bigger, right? So they're kind of pushing in all directions as they inflate. And so that tends to push them from the ground, and then they start to kind of bounce around and do things. So I actually wanted them to stick to the ground. That was the image that I saw, or the video that I saw online had that. So I was like, I really would like for them to stick to the ground. So I just wanted to add in some points that I could have as like a glue type constraint. And I'll show you in a second why there's two different ways you could maybe even go about doing that and why I chose the way I did. So here's the group promote. I promoted that up to a primitive because I needed that within the Vellum constraints node to be able to create the constraints the way I wanted them to. So really at this point, everything is ready to start doing simulation with it, right? Everything's ready to bring in and start to actually set up our Vellum properties and constraints and things like that. So that's about the extent to which I actually did any, geometry manipulation, let's just say. So let's take a look at what we've got going on here. And you'll see that this grid, actually I have this coming into this second node here, or the second chain as well. I don't actually remember if I ended up using this, but what that does is that brings it in as a collider, but it also allows you to set up constraints that look at this grid and are attached to that grid, basically, or to that geometry that's coming in there. So any geometry that you have coming into this this collision geometry kind of stream is going to allow you to be able to set up constraints to it and things like that. So it's that's just something to keep in mind when you're working with this. Like it's for collisions, but it's also has benefits when you're doing constraints as well. So just thinking about that, it actually might makes sense to take it out here. I'll think about that in a second as we're going through, but for right now, this should work out the way we want it to. So, all right, let's look at these and what we've got going on here. So first of all, just a cloth constraint. When you're working with things that are going to inflate, you want to have that cloth constraint, even though it might seem strange when you're trying to make something like a balloon, but really what this constraint is doing is making kind of the shell of your balloon, right? So in this case, you want it to be a really stretchy shell. If you're making fabric, like say like denim or something, you wouldn't want it to stretch really at all. But in this case, we want it to really stretch. So the first thing that I really went for was the stretch right here. So you can see the stiffness is set to about 6 and the multiplier is at 10. So that puts it at 60. A lot of times, I think by default, this is at, oh gosh, what is that? Is that a billion? I think. No, it's actually, I think that's a trillion. I think. Because let's see, if this is a million, 10 million, 100 million. No, sorry, it's 10 billion. If that was a trillion, man, phew. It's like, there's no way it's that big. Anyways, so normally this would be set to about a trillion, but, or 10 billion or whatever it is. But in this case, we have it set to 60. So this is really stretchy. It's very able to kind of be moved and stuff like that. So, So that was kind of my first thing I was thinking about, that I wanted to have set up. Now, another thing too that you can play around with a lot of times when you're doing these is the stiffness for the bend. So really what we're saying there is not how much it can kind of expand this way, kind of linearly across it, but how flexible it is like this. So if there's constraints that are kind of kind of all in the same plane, how much can they deform off of that plane? How easy is it for that to happen? Not how hard is it for these points to kind of stretch apart, but how easy is them to kind of move away from being on the same plane or from their rest position, however you want to look at that. So those are the two real properties that we had set up here. But another really important thing I find a lot of times when working with Vellum is messing with this density, because really what that's going to do is set up a mass attribute, right? So you can see here, we have a mass attribute, right? We have two different, this section is setting up two different important attributes. It's setting up mass and it's setting up P scale. So P scale is just going to say how thick basically is this cloth, right? How thick is this outer layer of geometry that we're working with here? So that's going to drive things like how do they collide with each other and how does it collide with the ground, things like that. You can tell that these numbers are quite small. They're not big at all, but this density, I think by default is set, I want to say it was set like this, calculate uniform, and what's this by default, 0.1? Yeah, something like that. But what I wanted to do, maybe it was set uniform. That might be what it is. And I think it was just too massive. I was playing around with it and it definitely wasn't working out right. So I can't exactly remember the reasoning behind me setting it that way. But a lot of times you'll see instability in your Vellum simulation, maybe a lot of jittering or things kind of bouncing around weird when they collide into each other. A lot of that can have to do with the mass, right? That's the wrong mass for the scale, things like that. So something important to kind of keep in mind is that mass attribute drives a lot of the simulation behaviors. So something to certainly keep in mind there as you're working with it, that can be helpful. And when you look at the calculate uniform, you can see here that this is creating a really, really, again, kind of uniform numerical value across the mass. And when you do the calculate varying, it allows it to kind of change if your mesh isn't like perfectly scaled or whatever, isn't, perfect, all the edges aren't perfect length. So I felt like the calculate varying was better in this case. There might be a better answer for that as to why you would choose one over the other, but that was just kind of my thought process there. So don't take it as gospel, but that was why I did it. So anyways, that sets up the Vellum cloth, right? And let's take a look at this too, because I think, it's great to know kind of how to set these up, but it's good to see what's coming out of here, I think. So let's go in here and you can see this is how the constraints are being made here. Let me shrink this down a little bit so it's a little bigger. This might be a little crazy to see on screen, but we have all of these constraints, right, that are set up and they're connecting to the actual points of the geometry, right? So it looks like a bit of a mess, but when you really break it down, each of these points matches up perfectly with the points of the original geometry, right? So when we look at like this, there's our original geometry points. And then if we, let's see, that's probably a fine way of showing it, actually. I'll turn this off. So you can kind of see it there that it's we've got all this Vellum cloth constraints and they're all connecting to these original points. And each of those have their own attributes on them, right? So those have things like rest length, right? So it calculates the length of it. It saves the original rest length, which is important. It shows the stiffness right there. There's the stretch stiffness. And then there's also, so, and it also puts on this constraint tag, which is really helpful to know, because this is a way that you can go and actually kind of call back to these constraints that we're making at each step here. So in this case, they've just been, most of the time, they're just named after the node name. They're just set to $OS. If you look down here at the bottom, you can see right there, there's the tags. So just a important thing to know, because you use that a lot. So anyways, that is the Vellum cloth setup, right? So the next thing that I did was add a pressure constraint type. And this makes really strange constraints. And I'm going to just look at this here real quick. So take a look at how this looks. Now, this is actually showing all of them. So let me just, let me actually put a blast node down, and I'm going to take out, let's see here. I'm going to take out all of the Vellum cloth 1. And these are the pressure constraints that are left. So these are kind of really weird. They're these zigzaggy kind of strange things. I honestly, I don't know what the math is behind these. I'm sure there's some sort of really great explanation for why they look like this. But the one thing that I really want to stress is this oddness here is that, well, it's actually kind of hard to see with the numbers. But if we look here, we only have 86 primitives. So all of these in this section here, if you can sort of see, these are all the same primitive. So this is 84. So if I go and select, if I go to select one of these primitives, that's all one primitive, right? So it's like a polyline, right? It's like a spaghetti's nest of, like a spaghetti bowl of I think I just mixed up metaphors there. Rat's nest, I think, and spaghetti bowl. I don't know. Spaghetti nest. That's interesting. Anyways, it's just all one primitive. And so I found that caused a little bit of trouble later on in working with this, because I wanted to do some things that weren't exactly it's not logical, I guess, in some ways, is the way that it works. Because if you put one object in there, right, one named object, the whole thing gets the same pressure constraint, right? So you can really only globally change the pressure of that, unless I'm missing something there, but that's what I'm understanding. So in this case, since I have all these little separate pieces, I can control them, but I couldn't change, let's just say, the pressure over here versus the pressure over here. Now, I guess it makes sense. It's logical, but it's one of those weird things where you're like, you want to break physics sometimes, and it's like a weird way that makes it a little tricky too. So anyways, just something to keep in mind when you're working with these pressure constraints and why they look so wacky and weird. So, okay. So we have, let me turn that off. That's crazy looking. Okay. So we've got this vellum pressure. I have this set to about 100 in the stiffness. Cool. I just slammed my knee into this thing under my desk, and that was really not comfortable. Ouch. Anyways, sorry. Trying to not freak out there. That hurt really bad. Let me take a quick break here. Hold on. All right. Who needs knees? Anyways, so this stiffness is not so much, it's the kind of pressure, right? It's talking about the pressure, but really what it's saying, as far as I understand it, is how much it can kind of give, right? So how much can it kind of fall back on itself? What's kind of its default like level of pressure, basically, inside of it. So that's kind of what I understood it to be. Your mileage may vary. Maybe I misunderstood that, but that in my playing around with it, that's what I found. So the last little element here is this glue to ground that I have set up. And what this is going to do is actually make sure that these boxes don't just go kind of flying around the scene, right? They don't just randomly kind of bounce around and do their own thing. I wanted them to stay relatively attached to the ground. However, there's another way that you could technically do this, and I did actually play with it a little bit, was with these pinpoints here. And you could do something like make soft pin types and things like that. But just having these pinpoints felt like it kept them a little too kind of stuck to the ground. Thanks, man. There's no crying. Thanks, Jack. Yeah, sometimes you just slam your knee into a keyboard tray that's installed for your wife when she uses this desk as a standing desk. So sometimes you just have to knee what feels like a razor blade. Anyways, so what I wanted to do here, instead of having it solidly stuck to the ground, was create something that had some give. And so the really nice thing with this is I can actually have it connect to the ground, right? And I can actually set the stretch of these, right? So I can actually set how much these are going to be allowed to stretch. So when we sim this and take a look at it, you'll see that these actually come up off the ground a little bit. They actually kind of bulge up and come back and move around a little bit. And I felt like that was a much more interesting simulation than it just all staying completely together. Now, the nice thing is it does actually pull it back into place, because it knows things like its rest length and, rest positions and things like that. It's able to kind of bring these little cubes kind of back into place. And I felt like that was a really kind of important thing to have going there. So that was why I did the glue to ground. And if you look here, I use the group ground glue, which if you remember is just all the primitives on the bottom here. And in fact, it actually gets promoted to primitives there from points. So that was what we're using as kind of the source here. So you can see this is kind of like the source geometry. And then it's using for target geometry, it's using the geometry that's coming into the collision here. So if I was to disconnect this, I believe it won't work. Yep, because there's no geometry there for it to see as a target. I could also set up groups here and things like that. But in this case, I just wanted the whole geometry to be the thing that it's looking at for the constraints. So that's kind of the idea of what's going on there. This is a whole nother thing that we're going to get into in a second. But for right now, let's just look at kind of how this static solver works and why there's two solvers that I have in line here. So the first solver here, what it's actually doing is it's doing a quasi-static solve. The reason was, I'll turn this off for a second. You can see that it kind of fell to the ground a little there. Oops. So if I hit play on this real quick and start going, it's going to actually kind of bounce and settle and have this little move kind of that happens there. And I didn't really want that, right? Yeah, I want those to blow up and do all that, but I didn't really want it to have that bounce at the beginning. I just wanted to start static. So what I did was just made a reference copy of this and set this into, I basically made a reference copy and then changed a few things. I basically went in this simulation here, changed the simulation type to quasi-static, made sure I set the cache memory enough to be able to fit it. It's probably would have been fine at 5, but I just made sure it had plenty. And then I also hit this clear dynamics checkbox, which should make sure that the output here doesn't have any like crazy extraneous solve information and stuff like that on it when it comes into the next step here, basically. So that was what I had set up there. Now that settles it down, and now everything's kind of in its nice steady state where it's kind of at rest. And from there, now I can solve this, and it's not going to have any jiggle at the beginning at all. It's just going to sit there completely still. So if I have like a loop or something that I wanted to do, it's not going to have that little bounce at the beginning, right? It's not going to have this little jump. So that's a little trick that I did here just to kind of kill any unwanted kind of settling at the first few frames. You could also pre-roll it. It's kind of the same as doing that, just without having to set up the time to be different and all that kind of stuff. So it's just a nice little thing because it kind of takes the pre-roll into its own step. And then whenever I update this, it doesn't have to pre-roll it every time, right? To settle it. Just has that saved and it's at a nice steady state. So just a little thing I did. Take it or leave it, but it was an idea that I had to make it so it wasn't bouncing at the beginning. Because at certain values it bounced more than at others. Obviously, that's kind of how something like a soft simulation like this would go. But then the thing that you might be saying is, okay, what is this doing? Because it's getting attributes and there's clearly stuff going on over here that I'm going to talk through in a second. But really what this is, what's mostly going on in here is a little SOP solver that's working on the constraint geometry. And really this is all that's going on in here. In fact, I can probably get rid of that. That's not needed anymore. So I'm basically just using this solver to bring data in from this other kind of chain here into the solver and have that work on the constraints. So what I needed to do was update the pressure, right? So I needed to update the pressure on each of these individual primitives. And the way I wanted to do that originally was let's see, there's a Vellum node called Vellum constraint properties. And this has the ability to do, I'll just show you what this looks like and we can kind of take a look at this real quick and why this didn't work the way I was hoping it would, which is unfortunate, but whatever, it is what it is. So what we can do is we can change the rest length scale of the group, which would be stretch, I guess. Let me see what that was named. Hold on, sorry. Oh, I didn't give this a group. I'll just call this. We'll just call this inflate. It's gonna have to do that again, but that's all right. All right, so now we'll be able to see that group inside of there, that stretch, those, oh, sorry, that's the glue to ground group. My bad. That's not what we wanted to do. The Vellum pressure. Let me look at this again here. It's actually this, and we'll call this inflate. I knew I was looking at the wrong one there. And this is the pressure node right here, the Vellum pressure node. And so let's go down here, let it do its little pre-roll thing, settle all the grid down, and that should be good. Cool. All right, so in here we should now see that there is an inflate. There sure is. And so if instead I was to do something like, I'm just going to turn this sim off for a second and just go ahead a few frames, set this to 1, then inflate it to, I don't know, we'll try 2. It's probably too much, but give it a shot. And then go back to 1 over a little bit longer scale here. So we're going to inflate and then back down. So let's just see what happens here, see how this works. Oh, it's off still. Turn that back on. Cool. All right. So now this is just going, you're going to see this inflate, but it's going to just globally inflate, which isn't really what we want, but let's just let it do its thing. So, okay, so we've got all these boxes that inflate up and do their thing, right? They get bigger. Oh, it's actually not as big as I was thinking. They didn't get as crazy as I thought they were going to. But so, okay, so they all inflated kind of globally, right? However, I want to be able to control that. And I was trying to figure out how I could get that to work. Now, what I could use is use a Vexpression and have some attributes come in here and make it, make that work. But for whatever reason, I couldn't get that to work. Now that I think is the best way of doing this. And I couldn't get it to inflate each attributes, each constraint separately. It wasn't doing it for whatever reason. So I'll show you this way. It's maybe not the best way of doing it. Who knows? But like I said, I'm always up for hearing your ideas or your thoughts. But I was trying to do a Vexpression when I first started it, and it just wasn't working. So I don't think it's in there still yet. So anyways, what I ended up doing was kind of changing this around a little bit. So let's take a look at this other section here. So first of all, I threw in an enumerate SOP to add an index into everything. That way I knew that I had an index for each of my primitives, just in case I needed to reference that, like if I split primitives out or whatever, I could at least use that to ID one primitive in one stream of data versus another. I knew kind of which one was which. So I just ID'd them that way, just so I had a nice index number. And then up here, I split out everything that wasn't the Vellum pressure. So everything that isn't Vellum pressure goes down this side. So if I go and put a null in here, you'll see that this is everything that isn't the Vellum pressure. So this is all of the constraints to the ground and the constraints that are the cloth. So I didn't want to do any animation on that. Wasn't needed, was totally pointless in this case. So that I didn't want to have any of that in there to mess around with that. So what I started to do was add in this inflate attribute. And so if we look at this, why is that not showing? There we go. Got to turn that on. So this is the inflate attribute that's kind of moving around here. So what I really love these attribute adjust nodes. This is the attribute adjust float node. You can see here I have it set to noise, so it's a noise pattern. And I've set the element size, the pulse duration, so like how quick it's moving through, like how quick the noise field is moving through. But the one thing I was really noticing was that it was a little too instantaneous in some cases, so I wasn't really super happy with that. But the other thing my wife mentioned when I showed it to her, I was like, hey, what do you think of this? She was like, I think they need to deflate as well, like not just stay inflated the whole time or like a box. I was like, oh, that's interesting. It kind of could be cool. So I threw this in as well, which is a random deflation. So this is adding a negative amount of noise to, a random amount of negative noise. And I've changed the remap value, so there's just a little bit of it coming in here. This is a bit higher, and there's some big chunk here that's actually all the way up. So there's some parts of it that'll be a little bit more like fully inflated and kind of moving around like that, but most of it is uninflated. And then down here, most of it's not deflated, except for just a little bit that is deflated. But I kept the element size relatively the same. Another connectivity, point connectivity. I'm not sure why I needed that. I'm sure there's a good reason. And then I attribute promoted here because this was working on the primitives and I needed it to be a point attribute because what I wanted to do was smooth this out. So I used chops to do that. So this is just a null that I'm using to look up in chops and then smooth it out using this right here. So once we get to this stage here, you can see that we now have a much smoother animation basically that's happening. I could have slowed it down a little bit, but I wanted it to still kind of be randomly moving a little bit and not just like kind of inflating and sitting there. I wanted it to inflate and then kind of come back down and then move over here and come back down. I didn't want it to be like this just slow inflation, deflation thing. So I was like, all right, I'm just going to take all this noise because it was kind of just popping on and off. I'm just going to smooth it out across the whole thing. So what I did is I brought the geometry in here. So I'm bringing in some geometry from this SOP line right here. I'm looking at the inflation attribute. I'm renaming it to inflate, which is the same. I'm not renaming it. And I'm organizing it. That's why I had the class attribute, because I'm organizing it by what connectivity it is. So all the points are connected together, and this works on points and not on primitives, I think is what I came to the realization of. So basically this geometry here is bringing in all of that as separate channels here. So you can see all the inflation right there. Oh, cool, Josh. Yeah, thank you so much. I'm glad that the UST tutorials have been helpful. Those were those actually did for part of, just from in my regular day job with side effects, and it was really I got to spend a lot of time on them. So I'm glad they're helpful and they came out well. So thank you. That means a lot. Thank you. So anyways, this is all of the different primitives, right? Being all smoothed out. And so what they look like when they originally come in is quite a bit noisier like this. Actually, you know what? Let me say graph per single channel. There we go. So this is what they look like kind of when they come in. And then once they get filtered, they get smoothed out quite a bit like this. So I use a filter to basically smooth it out. So I can smooth it out as much as I want to here. So maybe I wanted it a little bit noisier. I could add the filter width back in a little bit. But this is a way to just kind of take those attributes, make them a little bit smoother, because I liked what it was doing. I just felt like it was a little too noisy. So, and too jittery and crazy. Okay? Watch out. So let's take a look at what that looks like. So this is a little bit, a little bit in between what I had before. I could, let's see if I go back here, Just undo it. There we go. So we're back like that. Maybe 1 is a better number. Who knows? But basically the idea here is that when this gets exported here, it goes back to this channel SOP, and we're basically doing all the same thing in reverse, right? We're looking for the chop here, which is that's the chop network. And we're looking for the scope inflate, and we're organizing it by attribute class. So it's basically the exact opposite, bringing it back into SOPs and putting those attributes back onto the points. So that's just animating the point, and I'm in the wrong thing here. There we go. So you can see here we've got the inflation attribute, but again, this is on points, and we don't really want that. We want it to be on the primitive, so we have it right there and have it go back up. And now it's back at primitive level here. So we're animating each of those with their inflation level. And then finally, we've got this. So I wanted to add in something that would fade it up and down. And so what I did here was a couple things. I actually probably didn't need to do this because that ends up not really mattering because I had it in a separate chain. But one of the main things I wanted to do here was use this time ramp. So I set up this time ramp here to basically normalize between the start and end frame. You can see right here is where the start of the ramp, where it's going to start ramping up and where it's going to end ramping down. So it's going to be totally off by 228. So I could change this to be something even way less or way higher, like 60 and 100. And then once it gets up to 60, it's going to fade up. It's going to fade up pretty quick. Yep. Because this ramp is now a lot smaller. And then it's going to go for a little bit and then fade down when it gets to 100. So this was just a way to kind of fade those values in and out, across the whole thing, just with a little bit of X. I mean, you could do this with VOPs. There's probably a million other ways you could do it. But it was just the way that made the most sense in my head. So I think I had this line in here where it says constraint tag equals Vellum cloth. I think that was before I had this split up here because I had the cloth coming through as well, like this. So when you look at this, there's actually all the cloth basically around the outside, and I didn't want that to be getting any rest length scaling added to it or anything like that. I didn't want that to be getting affected by it. So that was why that little attribute was in there. It's also yelling at me here because these are floats and they're not integers. So I should really have this set to CHI. I don't think that's going to change it, but what I could do is just go into parameter interface. I think I can change these to integers like that. Perfect. So now they're integers. Cool. Anyways, so I merged those two back together because we need all the constraints exactly the same way that they were, because we want to be able to reference those in. And then here's the out animation with the inflation and everything. So that's all that I had to do kind of to get that inflation attribute basically. And then I'm using this null here to go inside of this Vellum network at like 63 frames in. So it's trying to simulate it. Stop it. So in my SOP solver here, what I do is I object merge in all of that that I just did. So I'm actually looking at that null that I made. So I'm object merging in all of those constraints, right, from the out anim inflate, which is just this node right here. And so inside of here, I'm then using just an attribute copy, matching it by index. So I use that index attribute to match those together, right? I remember I said that I had those two different streams of primitives that I wanted to be able to kind of match them together. And so in this case, I'm using that attribute copy to make sure that they're matching up based on the index attribute. And we're just grabbing the inflation value there. So this is coming in and is setting that to the, setting the attribute inflate on each of these pieces here, just copying it over from that geometry, bringing it in. So it's copying it over onto the DOP geometry. And then in here, let's see, what am I doing here? Inflate. Yes. So what I needed to do is have a way to be able to take how, on a scale of from 0 to 1, and say, based on how inflated this thing is, right? I want it to then contribute to a multiplier of the rest length. Well, you don't want it to multiply 0 to 1, because then 0 means it's the rest length is 0 and it just collapses in on itself. So that's not what you want. So what I did was brought that inflation in, I bound it in, and then I did a fit. So I know that the source minimum here is going to actually be -1 now that I'm thinking of it, because it's going from -1 to 1. And that is, that's going to be based on if it's deflated, because it can actually go down, but not always. That doesn't mean, so it's actually negative because it's actually like losing in pressure inside of there. So I have it set from -1 to 1. It's outputting that as 0 to 1 because I want to use a ramp to be able to kind of control how that gets, use the ramp to kind of control how that maps onto that attribute. So what I have here set up is I have this ramp is actually controlling my range for how the multiplier is being applied. So I don't think I knew this until I did the Joy of X stuff with Matt, which was a couple months ago, that these ramps can actually go past 0 to 1, like vertically, very easily. Like left to right, they don't want to go past 0 to 1. But once I normalized it, the value, from -1 to 1 and moved it to 0 to 1, now I can use that. And I know that, so 0.5 is the middle. I know that should be 1, because that means it's just the rest length is the rest length. If it goes down to 0, which was the old -1, I know that I want it to go down to whatever this attribute is, 0.1. So when it deflates, it's only like 0.1% inflated, right? So it's just barely got a little pressure inside of it. But on the other side, when it goes way inflated, it actually goes up to a value of 4. So that's kind of an interesting thing. You don't really think of these as like, hey, I could set this up way higher and it could go up to like 10, right? Like you just don't think of these ramps that way, but they do. They can work like that. So now I have it so that it goes up to 10. So we can just kind of sim that real quick and see the difference there. I had this blast just to look at the constraints, just kind of visualize them in here, but the out is actually what's coming out. So basically that was just a way to easily transfer those attributes into DOPS and have it work within the simulation. Because coming into this Vellum solver, it wasn't respecting the animation coming in here. There's probably a way to go in and tweak that. And if I set this all up in DOPS, I certainly could make it do that. But in this case, I really just wanted the animation. So I was like, I think I can just do it with a SOP solver in there and just call it a day. So let's take a look at what this looks like with 10. It probably will look crazy, but might as well just look at it. So with that ramp, basically you can set each range to have like a different, like it doesn't have to be linear to each other. And so in this case, you'll see how they really can push out of the way of each other, but they won't just like fly around, right? And so that those ground kind of glue constraints are holding it down, but not holding it rigid, right? So it's kind of a nice little bonus, I think, in there to have where it allows it to be held to the ground, but not like rigidly constrained, where it can actually move around and flex a little bit. I think it makes it a little bit more interesting. Now, obviously, that inflation is insane comparatively. It's not at all what I was intending for it to be. I think it was set to 4 originally, so that's a little bit better. And again, just to show you, this is what the actual end kind of simulation looks like here. All right, so we have these pieces kind of inflating and moving around and stuff. You can see how they kind of are able to kind of move up from the ground a little bit, but then once the inflation value isn't pushing against the ground, they kind of snap back down. And so I think it's sort of an interesting effect. The other thing you can think of too here is that you could do something like use an attribute transfer or something like an attribute from distance and use another object to kind of move around in here and actually control where those, inflation kind of centers are happening. So you could use an object to kind of move that around and get an attribute like inflate from that, and then drive this whole simulation basically the same way. It just would be defined by an object instead of just by random noise. So that's an option as well. I didn't go that direction. I just thought it was a little more interesting to play around with noise and get it to do more or less what I wanted it to. So the only thing that I was kind of like frustrated with at this point was I don't get that inflation attribute at the end, right? It comes on these on the constraint geometry, so it actually would be stored there. So if I put a null down and we take a look at this, we'll see that this should have that. It's kind of fun to see like that too. It's like real funky looking. It does have the inflate attribute on it. However, that's only on the constraints. Hey, how's it going? Kavale, maybe? Thanks for joining us. Greetings from Norway. Wow. Jeez. You're a night owl, man. That must be late. Greetings. Well, thanks for joining us. Anyways, so what I did was I knew I had the attributes right here, and I had the I had them all just animating here, and I knew it was, this calculates super quick. It's not a heavy calculation. So I was like, well, I'll just take the inflation attribute here, move it over to points. Yeah, I don't know why I did it that way, but I did it, and then just copied it over the inflate attribute based on the position. And then when I put it in here into the Vellum post process, this just helps subdivide it a little bit more. Kind of makes it a little bit smoother, not so. Oh man, well, everybody pour one out for our friend from Norway here. He ran out of memory and had to resubmit a job. Oh, it's always a fun feeling, right? Well, my condolences on your sim running out of memory, but glad to have you with us anyways. So hopefully I'll keep you awake while you're checking all your stuff over. So anyways, we've got the inflation attribute on here now. And I can use that, for rendering and things like that. And that was kind of my idea. So at this point, I just kind of deleted some attributes that I didn't need, just cleaned it up a little, deleted any groups that I wasn't really going to need. And then I had this saved out on my other computer, but let me just save it to disk in the background here, let it run for a second. And that'll cache out the Vellum sim with the subdivision on it so that it doesn't have to calculate that all the time. So that shouldn't take too long. And then why did I have another? Oh, I think I meant to get rid of class earlier and I didn't. No. Oh, right. Sorry. This is a primitive class attribute and I wanted it to be a point class attribute. And then just had a little color that I added to it there just to do something interesting. And I'll show you what I did in Solaris in a second here. So let's just... All right, we'll just grab a frame here. That's good. Yeah, probably it'll be pretty well simmed in a second here. So yeah, somewhere in there is cool. All right, so I made a Solaris. So that's pretty much the whole thing, how this all works. I'm sure there's a few things here and there that could certainly be done smarter, but sometimes getting it done is more important than doing it the absolute perfect way. So I've come back up here. I have everything in Solaris. I actually had it way bigger than I wanted to be. It's like gigantic in here. And when I was messing with the camera settings, I was like, oh, that was stupid. I shouldn't have had it so big. So I transformed it down. But one thing to keep in mind here when you're bringing in like animated geometry, especially into Solaris, is let me just see if this is done. I'll let this finish up. But I'm going to jump into just a quick little touch on some USD stuff just so that you know why I did what I did here. But hopefully this will be happy with me. I'm just going to hit save in case not. But just go into Solaris desktop. Cool. All right. That's fine. A little bit of a different desktop here, but we've got our Solaris stuff set up. So when you bring in something like the inflatable boxes here, right? So each of these chunks is going to come in as their own mesh because named when you bring things in, anything that's a name attribute is going to try to separate into separate primitives. So in this case, names usually will normally turn into separate meshes. But when we look at something like our points, and we have these changing values here, right? For these boxes, right? You can see that these values are changing all the time. So if we don't look at the scene graph details, but instead I'm going to look at the scene graph layers. Oops, that was a mistake. Didn't mean to click that one. And we look at our inflatable boxes. So each of these are layers that are coming in, right? So in this case, I'll just change this to an editable layer there, and we'll look at this from the top because this will, we know for sure that this is what this is. This lop layer is that. So if we look at this, what we actually do is, this might not be maybe clear from the start, maybe from just looking at this crazy list of things. But basically what Solaris does and what USD does is it writes all of your animated attributes, animated, point positions and things like that all at once. So that's actually why I was caching out that information. So it wouldn't have to, this shouldn't change. I don't think if we move this around in here, these numbers and things like that, none of these values should be changing because this is actually the USD file. It's gigantic, but it's actually not as big as you might think. Let's see here. That's interesting. Anyways, I don't know why it's doing it that way. It's a little strange. But what USD likes to do is have everything written all at once, right? That's like the way that USD likes to do it. It likes to, when you have an animated file, it's all in one file. All the time samples are written out and everything. So that was why I had it caching out the subdivision and stuff here, so that there wasn't any anything that had to really be calculated if something needs to get updated or whatever. It was just all ready to kind of go right into Solaris. So anyways, that was my reasoning there. Maybe misguided, actually, who knows? But I'm pretty sure that will help a little bit when you're bringing things in here that's animated, just having it all cached on disk and ready to come over into Solaris. So I just put a floor in, brought in the camera here that I had set up. It was too far. I think I edited the camera. Yep, there we go. And then added a few lights in, added some shaders. These are just a couple of Material X shaders, nothing fancy there. I also added a physical lens shader in because I wanted to do something sort of interesting there. And what I actually have going on, in this one, shaders here in the boxes, there is the inflate primvar that's being read in here by the USD primvar reader. It's reading an inflate and using that to drive the emission. And then the geometry color is driving the emission color. So that's the only one that's actually got anything really going on in it. And then I've got this physical lens set up to add some interesting lens characteristics and things like that. So I'm going to turn this off XPU because I don't think my stream likes it when I run XPU, but that's okay. I'll just snap this over to Karma. I'm on a computer that can handle it, so I think it'll be a little happier than on my laptop. But what we should get here is a nice little scene going here. And added a few lights just for some reflections and things like that. Now, this is lower quality samples than what I had running in XPU. I had a few more samples, but it denoises and does its thing. But so that's kind of the idea there. I've got some boxes that are inflating and whatnot, and they all are random different colors. And as they inflate, they get brighter and then emit some light into the scene. And I also have a curvature and physical lens shader here. So if I say do nothing, that should go back to the way it was. And then that's with a little bit of curvature, a little bit of chromatic aberration, just to give it a little bit of grit and interest, maybe. I don't know, something. So that was kind of my little thanks. Yeah, just a random little thing to do there. Just try and I like random glowy things, so I just did that. And my wife's a graphic designer, and she actually helped me with a lot of the different random lights and things like that. And actually, when I'm looking at this now too, I'm thinking about this. I think that this is actually creating a negative emission right there. Now that I'm looking at that, I don't know if it does that in Karma XPU. It might be clamped in Karma XPU, because I don't remember seeing it that way. And that was what I was doing on my look dev in. And so I wonder if I could change that. I bet you I could. Let's go in here and see if we can't tweak that a little bit here. So it'll be this. And I think what we would do is set that to, is there a clamp? Yeah, there we go. So I'm just going to clamp that. See if that does. Yep, sure enough. So for whatever reason, standard Karma CPU didn't like that as much as XPU dealt with it, but that's fine. Probably smarter to have a clamp on there anyways, because there's negative values coming in there, and I wasn't really thinking of that. But just I guess a nice little caveat to make there too is that a lot of times people will be using Karma XPU and CPU and be like, oh yeah, it's the same thing. You're just using you're just adding GPU usage into it. However, they are different renderers. So the code is like, I don't want to say completely different, but they are certainly different render delegates in Solaris. So something to keep in mind there, that they're not going to perfectly always match up to each other. So that's kind of the effect that I had set up here. And where are we? We got zoomed way in. So so that was kind of the way to be able to take this then and bring it into Karma, into Solaris, to render. A lot of people, I've heard some people say that they struggle with bringing things into Solaris, and that it's tricky, and it feels like a way I mainly talk with professors and teachers that have been teaching Mantra for years, or different render engines and things like that, and they just say that it's like, oh, it's so different to have to bring things into Karma. It's such a different workflow within Solaris and all that kind of stuff. But I think one of the best things to kind of get your mind around is how, I'm going to go back over to Solaris here. I'm going to turn this back to GL, is how some things are weird. Like something to keep in mind too in Solaris is that the viewport is dependent on the scene composing like all the time. Like the viewport is also completely different than the OpenGL viewport in Houdini standard. So just keep that in mind. Like sometimes just moving your flag is going to help just refresh this. It doesn't have some of those same weird little glitchy things sometimes that happens in standard GL and Houdini. It has some of its own little quirks. But I think there are hopefully some improvements coming to both in the not too distant future, I hope. I know that there's been talk of that. So who knows what's all coming, but hopefully those will be some things that will be in the past a little bit more. But anyways, when you're doing something like a SOP import here, just remember that you can always change the way that you're importing your data here. So like for example, this partition attributes, say you had geometry meshes that had, separate shaders that needed to be defined on them. This partition attributes can actually do that. Now I don't have anything. This is just going to partition it by name. It's not really going to be anything separate here because we're already using name. But let's just say you had like a shop material path. You can actually create little geometry subsets underneath these meshes that you can use to assign shaders to specific parts of a mesh. So that's one thing to keep in mind when you're doing that. And also, there's some ways that you can do that within the material assign as well. You can do some things procedurally in there using geometry subsets to be able to assign shaders to, and create shader assignments based on your shot material path attribute, I think is how it works. But it's been a couple months since I've done that, so I have to rethink that. But anyways, this is the stuff to really keep an eye on here. So like when you're bringing things in here, like what are we doing with packed primitives? Like, cause those have to be changed over. What are we doing with, different types of surfaces? Here's the path attributes, right? So here we have it with path and name, but if I take name out here, that's just going to make one mesh for this whole piece of geometry. Now it doesn't inherently change anything right now. Like it's all working the same. However, it is now all just one mesh primitive, right? So that might be beneficial to you. Maybe you have a path attribute set up and just want to use that. You could use that as well. And that path attribute would actually set up where these primitives live. So I believe now if we come down to this partition attributes and say by name, sure enough, now we have all of these separate chunks as geometry subsets. And we have by default, you can see right here, whenever something's grayed out like this, it doesn't mean it's not happening. It just means that this default is what's being controlled. So when you turn this on, it allows you to change this. So if you don't want it to prefix the subsets with the attribute name, we just say piece 0 chunk 0, you can do that. So some of these things are really important to be able to use basically and work with in Solaris when your geometry is coming in. So just something to keep in mind. I know there's still some growing pains with working in Solaris, working with USD. It's changing all the time. So that I think can be kind of hard to deal with. Anyways, I'm getting on a soapbox about USD. That's what I've been working with my day-to-day work for a year now. So I'm a little bit in USD world. I prefer, yeah, cool. Okay, 9hole. Thanks for posting that. I feel like I know that name. I feel like I know that username for some reason. I might know you from somewhere, but I'm sorry if I'm forgetting where I know you from. But anyways, yeah, that's cool. I prefer Solaris lights, materials, ROPs in one place. My students really liked it, as long as we kept it simple and just SOP import. Yeah, jumping networks, so lightweight. Yeah, thanks for covering SOP Solaris more and simplifying. Yeah, for sure, of course. Oh, okay. You were in the meeting today. Oh, right. Cool. Oh, well, cool. Well, welcome. Yeah, awesome. Very cool. Yeah. We have a little office hours thing for professors and teachers and instructors, Houdini instructors around the world, and yeah, we had our office hours thing today. So that's cool. Awesome. That's where I know you from. Very cool. Well, welcome. Thank you for joining the stream today. Yeah, I think it is a little simpler. I really like the Solaris workflow versus doing things in object level. I feel like it's so much cleaner. You don't have to go into, ROPs and things like that and all those different things. It just is, it feels like a much cleaner workflow to me. Your shaders are in a node in your network. Your lights are nodes in the network. It makes it, I think, easier to set up separate, shots and things like that. You could create a base look and then modify it multiple times to different branches and make different kind of scenes that way. So yeah, I think it's a really strong workflow, and hopefully just getting so the question is, do you go from LOPs to TOPS much with USD? The most that I do with TOPS in USD really is just for I did some stuff with processing assets. If you look, I just within the last couple weeks released a course on asset building with USD asset building, and it really talks more about the structuring of assets and things like that. But in there, I have a top network that's just basically running the component builder. It's just processing nodes and processing assets coming in and then converting them into USD, using the component builder to kind of standardize them all. That was, and assign, have it procedurally kind of assign shaders through that, and kind of loop through it. So really that's the most that I've done with it. Haven't really done too much with tops in USD specifically, but processing attributes, yeah, for sure. If you look at it, it's once I get into talking about, there's like a shelf scene that I make in there. Once I get into talking about that, the first video I think highlights just the top network that I set up in there, but it's nothing crazy. It wouldn't be anything overly complicated, but it is certainly working with it, bringing geometry in and helping process it and stuff like that. So that's mainly what I use it for. I'm also doing, I'm in more of the teaching world, right? In more of the training world. So for me, I haven't been in the production world as much, but if I was probably doing stuff in production, I can see it becoming something that I would use a lot more, in production. So, oh yes. For lop to top, then iterate over prims. Yeah, that's interesting. Yeah, I haven't done anything like that yet. No. The other thing too with, with working with USD, a lot of people think that, and this will hopefully be my last little soapbox on this, but a lot of people think that with Solaris coming in now, you have to do everything in Solaris, and that's like its own little, like you have to do your SOP import at the beginning, and that's like you start your geometry there, and then you edit it later in the network, and then you do this down here and stuff like that. And I don't really like to work that way. I feel like Solaris is really made more for when your assets are pretty much finalized to bring in. Not to say that you can't do stuff with them, but I don't find USD to be a really great medium for, while you're working in Solaris, to have a lot of, it's not really great to be able to be editing and tweaking stuff in there. Just causes, I feel like, headaches. So for me, I haven't really gotten into anything like that, where I've pretty much everything I'm bringing into USD, into Solaris, is ready to go more or less, and has been cleaned up and prepared. And then I'm just kind of, assigning things and stuff like that, not really doing anything with primitives or assigning anything like that. So I haven't really done that. But I actually, yeah, I see what you're saying about primitives in your scene graph tree, right? Iterating over those. I'm thinking primitives like in your geometry, but yeah, I don't know how much the scene graph tree comes in. It's an interesting idea. I don't know. I don't know how much you can really interact with the scene graph with that, but yeah, it's an interesting question. Maybe I should play around with that a little bit, see what exactly that does. But yeah, cool. Honestly, not a ton that I've seen. In fact, so the question was, are there any examples out there for lops to tops? If you're not familiar with tops is the task operators. It's PDG. So it's all, you can basically turn your computer into like a small, almost like pipeline render farm, processing, machine, with work items and things like that. And so that's what, 9hole here is asking about. Yeah, you can get the Python modules within USD are really powerful. That's really actually the main way that you interact with USD in like parameters and stuff. There is actually, they never made any like what is this, HScript, right? They never made any HScript expression languages. Really only Python is something that's available in these to work with parameters. There's no USD expression. So yeah, the you can do a ton with Python. It's crazy. But there's not a ton, like tops is still a very under represented kind of topic for information out there. So that was why the education team just at the end of last year had our intern actually do a whole series on introduction to tops and like explaining that to people. But we want to keep expanding through that. So that certainly will be something I'm sure we'll be looking into more and more, and maybe something that we could add as a resource out there. So no, it's a great question. Yeah, having more LOPS and TOPS integration would be key, would be great, I think, especially with Solaris being so heavily introduced into studios, into their pipelines and things. So yeah, it's a great question. Very good. So it's about 9:30. It's a little early for me to end, but I think I'm going to oh, that's an interesting point. I found Python slow in LOPS. So like you said, going to LOPS to finish. Yeah, I mean, I think it depends maybe on what you're doing specifically. And it also depends on how you're traversing your scene graph tree, because that could also have to do with it as well, because traversal is a big thing within Solaris. You don't want to be looking at every single primitive all the time. So that can be a tricky thing. The person to talk to about Python and LOPS is if you're on any of the if you're on like the Discord servers. I think he's on the public Discord server, but Chris Rydalch is a great person. If you ever see him out around or see him anywhere out on the forums or whatever, I think his name is like Goldleaf, I think is his handle. But he's a great guy to ask about Python, because there's so much Python in the component builder stuff. Like pretty much like half of what it does is done with Python. So crack that open and see what he's doing in there, because there's probably a master class on Python in there as far as USD Python. So there's a ton in there. So I would recommend taking a look at that if you're interested in more details about Python in USD. There's a ton in there. That's what, at least that I found. So no, it's not late for me. No, I'm just I was just about to say that yeah, I think that probably this is where we'll end the stream for the evening. A little earlier for me than usual, but I think hopefully this gives you a good little walkthrough of something and some information to kind of take a look at. Maybe play around with on your own, play around with pressure and simulation and stuff like that with Vellum. The one thing I want to reiterate again is that we're gonna have another guest next week. I will be at FMX in Germany. So if anybody's watching this and you're from Germany, or you're going to be in Germany for FMX, hit me up on the Discord and say, hey, I'll be there. Do you want to meet up or whatever? So be happy to do that. That'd be super fun. Always fun to get to meet people in real life instead of just seeing text on screen. It's always nice to have a face to put to it. But next week we'll be in Germany for that. So I won't be available here because it'll be even later. But the week after, on the 2nd of May, again, we're gonna have Mark Fancher on from Already Been Chewed, and he's gonna be talking about his workflows and things like that he's doing. And I know recently he's done some cool cloth draping stuff for us in a workshop at Texas A&M, and he's just he's a great guy and a wealth of knowledge. So I think it'll be a really great conversation, and he'll probably let me know a little closer exactly what specific topic we'll be talking about, because I know he's got some stuff that he's either trying to finish up or I think he might have finished up that he's going to talk about on the stream. So hopefully that'll be a really cool conversation and get to see some really neat stuff from him, rather than just my kind of programmer art that I normally do. So it's always nice to see some actual production examples and some things that people have been working on that are out in the field doing stuff. So that is my plan for the 2nd. And if anything changes, we will certainly I'll certainly update the Discord and social links and things like that. By the way, if you want to join the Discord, it's on Houdini Hangout. So there's the link to it. Hopefully that should come through. Yeah. On the, you can get that. You can get an invite link there and join the Discord, and place to add, questions, comments, anything like that, anything you might have learned recently, whatever. Place for discussion, and a place where I post announcements for the stream and things like that. So, but yeah, that's it for tonight. Thank you guys so much for joining, and I will see you guys in a little bit. Thanks so much.